Hi, I'm Todd Murphy. I'm an engineer here at Root3 Labs. Today we're going to talk about the workflow we use to get parts modeled in Solidworks and get them all the way through to run the job on our CNC router. This has been a great little tool we've had for a number of years, and while there's a lot of overlap between what could be done with this versus the CNC mill we also have here in the shop, this still does have its important uses. Sometimes when we're looking for really high spindle speeds or working with softer materials, it just kind of makes more sense to jump on this machine.
Now, the first big step in the process is making a solid model. We mostly use Solidworks at Root3 for our solid modeling, and for this video I decided to just work up something quick that would highlight the 3D milling capabilities of the router. So I grabbed a piece of plywood, modeled that, and then you'll see me add in some layered pockets at different depths. As always, when designing a part, you need to think about how it's going to be made, so then you'll see me add in some fillets with a radius just a little bit bigger than that of the router bit I planned to use to round out the corners. The next step after this will be to generate a CAM toolpath. We've used both Solidworks CAM and the Autodesk HSM Works package to generate G-code for our models with good success. Today I'm going to use a Solidworks CAM just to keep it simple. And while this isn't a tutorial on how to use either of those CAM solutions, it's worth mentioning that the general flow is that you need to configure the CAM to give some basics about how the piece will be oriented in the machine and what commands should be generated, including the speeds and feeds. So here we are with a modeled part, and now I'm going to try to get everything set up for the CAM path. You can generally follow the workflow going across here. Just to note, if we're going to define machine, I've already defined a machine that has some of the details about the Shapeoko router in there. I set up the tool crib, knowing that I wasn't planning on any tool changes with just the one router I'm going to use. I've chosen the post processor for the Shapeoko. This Mach 3 post processor is what's recommended and works well for us. And then you can just kind of, again, work your way across. So we looked for machinable features, generate an operational plan, and generate the toolpath. It's always a good idea to simulate it, just as that last double check to make sure it makes sense what you're seeing. The last step then is to generate the code. Pick your post processor, where you're going to dump it, and we are moving from here to bCNC as the code sender, so I know that it wants an NC file. So now here in bCNC we open up the file that we just created, and we can see what the machine is planning to do. This whole workflow is not flawless. Working with the different CAM generators, we have found that some commands get generated which we don't want or which cause problems for us. So it's not uncommon that we come into the editor here to comment those things out. From there, the next step is to run a homing cycle for the machine. I'm showing that faster here than it actually happens. And I also like to use the feature to run it around the extents of the planned movements to make sure we don't have any collisions. And now, finally, it's time to cut.